quickly introduce everyone to you so that they understand who you are, where you're working, and everything. Akshay, actually, I met Akshay at a networking platform, and he was telling me about his company and the kind of the company that he's working with and the kind of work that they're doing, and I found both of them really interesting. So, from what I understand, you're born and brought up in Solapur, right?
Yes.
Maharashtra, right? He, just like me, is very completely into cricket and actually played for the Maharashtra Under-17 cricket team in 2007, right?
I was
Uh,
a part of the selection camp for the team.
okay, that's great.
They had a 6-month long selection camp.
Okay, that's awesome. Uh, he's a BTech in mechanical engineering from College of Engineering Pune. He's previously worked with companies in R&D at Mercedes Benz and Idiada Automotive uh, previously, and Akshay has been working for the past few years, about 4 to 5 years with MACPL. I'll get a little bit into that as well about the company, and I think you were the one of the first members of the R&D team, and you are currently working on innovation and product design, right?
Yes.
Okay, perfect. So just to give everybody a brief input on MACPL as well. So MACPL is Marathwada Compo Private Limited, and which develops complex and technically challenging auto components, and which is majorly contributing to safety of the vehicle. They are a tier one supplier of to two-wheeler and three-wheeler OEMs in India and overseas. Um, they also do heavy fabrication of earth moving equipment. So the customers range like big names like Bajaj Auto, TVS, Piaggio, Hyundai, JCB. It's just a few of their customers right now. And I believe you have facilities in Aurangabad and Hosur, Tamil Nadu, and Aurangabad in Maharashtra, right?
Yes. Yes.
Yeah, and when I was talking to you for the first time, I think you were telling me about the innovative products that you are doing in other domains, not in automotive, but in other domains.
Yes.
And when you were telling me about that, I thought that this is something that we should definitely share with the world, and we should talk a little bit more about that. Just when I was having that first conversation with you, I think one thing that struck me was your work culture in general. Uh, could you I think, could you talk a little bit about the work culture at MACPL?
Yeah. So there are major three aspects of the work culture at MACPL according to. So the first is freedom. The second is continuous upgradation, and the third is a fail forward philosophy. Okay, so freedom basically means we have the freedom to build it, to manage things the way we think is better, like in terms of time and in terms of getting the achieving the targets. Plus, we also have the freedom to decide on a lot of technical aspects, like how the product should be, how it should perform a certain function, all of that. So just to give you a small example, we were having a technical discussion with the vice chairman of our group and our managing director, Mr. Ajit Saundalgikar. So when we put in front of him the technical challenge that we were facing, so he himself is a technical person. So he from his side he gave us some inputs, and then he was like, "These are just ideas or inputs from my side. So you have been working with this problem since a pretty long time, and you are more aware about the problem. So if you have any other ideas, you test those as well. You test this as well. Whichever you find out to be the most suitable to solve the problem, you go ahead with that. So that kind of freedom we have here. So we have ideas for any problem coming from the GETs to the head of the department. All of the ideas we collect together. So then it is like these are the ideas. We put it who has given the idea aside, and we test all of those ideas. So which of the ideas is most suitable for for solving a certain problem or for the specific application on which we are working, we go ahead with that. So
Yeah, I think that's a very important factor in terms of believing in the competence of the team and not micromanaging. Even when it's a big project or a small project, there's a tendency for the management to usually get into the micromanagement and solve it in a certain way. I think that's a good thing that you're doing. The freedom definitely resonates. Uh,
yes,
in innovation, it's important. Yeah,
yeah, extremely important.
yeah, uh,
Then the
yeah,
second aspect of the culture is continuous upgradation. So it is like we keep learning new things and we keep implementing them in our work. So what we do is we are, as an individual, we are upgrading ourselves. Plus, we are as a team, we are upgrading, and as an organization also, we are learning new things, implementing them, and improving the work that we do. Just to give you an example, when I had joined the company after 2-3 months, we did this systematic innovation techniques workshop. So it is called as TRIZ. It is a Russian methodology. So I did the level 1 of that uh, methodology and then the level 2 workshop as well. So this way we came to know, okay, if we want to innovate, what are the different techniques by which we can have different ideas, how we can innovate. So that after learning those, we have been implementing them slowly, and we have been getting good results, good ideas. Just another example, you must have heard about the lean startup methodology.
yeah,
So,
absolutely. Yeah,
yeah,
I
so
know that.
many startups use that methodology to find out a product market fit.
Right.
So, the methodology, when we learned it, we thought it to be more related to the software part of it. So, what we did was I mean, understood what is at the core of the methodology and modified it a bit to suit the product design methodology that we have or the structure that we have. And when we have actually started implementing that, we have been getting very good results because not only we are getting good ideas from the innovative methodologies that we are implementing, we are also able to put those ideas in practice quicker, faster, so as to achieve the results in a pretty short amount of time. So
Right.
that is how the continuous upgradation culture works here. Then the third aspect is fail forward philosophy. So basically, it means is if you are walking and if you fall forward, when you get up, you already are a step or two ahead of where you were. So in the work we do, and especially in the innovation world, failure is like there will be many times we'll be failing before we succeed. So fail forward philosophy basically means that when you are failing, you make sure you fail in such a way that when you learn from the failure, you will be moving ahead.
Right. Right.
Yes. So one of our directors, Mr. Mihir Sondalgekar, he encourages a lot in this aspect. He's a big promoter of the fail forward philosophy.
Yeah, I feel like all these three values have very deep rooted requirements for innovation and product design in general. And for
Yes.
any technical company, I think these three are very important.
Yes.
We definitely want to talk, I want to talk a little more on the Russian innovation, systematic innovation technique. I think
Yes.
that'll be an interesting conversation. Um, do you essentially follow any methodology?
Yes, so since we are working on novel products, there is a different kind of a methodology that we follow. So, just to give you an example to connect more easily, you must have come across shooting ranges, right?
Right.
So, in a shooting range, we have a target which has this circles, and the target is supposed to be hit by a bullet, and we have rifles or guns to hit the bullet, like fire the bullet. So if we consider such a shooting range, we can say any business is similar to a shooting range, wherein the bullet is the product of the business. The target is like the target market or the target customer, and the gun is like the facility of the organization, the manufacturing facility, the operations facility, logistics, marketing, sales, etc.
Yeah, the organization.
And
Right.
yes, yes. So these all work together to deliver the product, that is fire the bullet. Okay, and then the bullet penetrates into the target. So the penetration we can call as the sales numbers, the sales.
Yeah.
Yeah. Okay. So in any organization, operations form like most of the part. Okay, so we can, in this case, we can say that I mean, shooting the bullets to the target, then reloading the guns with new bullets for shooting the targets, and shooting like maybe 1,000 times in a day or so. These are the kind of, we can say, operations of the shooting range. So businesses also have similar kind of operations, right? We have to deliver X number of products in a day, in a month. Then we have there are other associated problems with the operations, like the gun is getting heated while we are shooting continuously. So there will be some problems with the manufacturing facilities, the logistics, etc., etc. So those have to be solved to keep the system running so that the products are delivered. So this is what an operations of an organization would form. Now there are, I mean, some people in the organization which work in the research and development part. So they are not so much related to the operations, but they are more related to the continuous improvement, increasing the performance, optimizing the product, improving efficiency, etc., etc. So in this case, for the shooting range example, we can say increasing the gunpowder in the bullet so that it can move faster. Okay, then reducing the drag of the bullet, having the shape of the bullet in such a way that the drag would be the least. So these all would come in the continuous improvement, performance improvement, efficiency improvement points. So whenever usually like from the top management, these targets are, I mean, there are targets which are given. Like last year, the sales was like 80%. This year, I mean, from the market, we have a 80% penetration. We need it to increase to 85%. So in the shooting range example, we can correlate like previously it was penetrating into the target only till 80%. Now it has to penetrate to 85%. Okay, so for that, either we'll have to increase the velocity, reduce the drag, all of these continuous improvement or optimization stuff need to be done. Okay,
Yeah.
so those would come under research and development. Okay. So what we are currently working on is completely novel products in which we have to provide some value which is completely different from the one which we have been providing or which others have been providing.
Right.
Okay. So in the same example, we can consider that right now we have been shooting bullets at the target. So suppose we have been shooting from like a distance of 50 meters only. So now the new requirement that we have is the target is covered by a bulletproof jacket.
Hmm.
Okay, and now we have to shoot it in such a way that the bullet has to penetrate the jacket and then into the target.
Yeah.
Okay, so suppose there is an expert shooter. So when he is given this kind of a challenge that he has to hit the target on which there is a bulletproof jacket, he's extremely excited, right? He's an expert. He said, "I can shoot it. I can like penetrate it and stuff." So he takes the gun, he starts shooting. So since he is an expert, on the target, he'll be shooting at the center, right?
Right.
But since the bullet is not capable enough to penetrate the bulletproof jacket, the target is not hit. Although he is doing it perfectly, but it is not able to penetrate. So like whenever we have a new requirement, whatever we have been doing, even if we are completely into it, the I the what we can say, the highest expertise we have related to that, since the situation has now changed, even though we are doing everything correctly, we are not able to have that kind of penetration or that kind of sales, because we have to add certain value and we are trying to do things the way we have been doing before.
Right.
Okay.
Absolutely.
So going by this approach here does not work. Okay. If we take the research and development approach, continuous improvement and improving the performance, we'll say we'll increase the gunpowder in the bullet by 10 times, so that it can achieve a 10 times velocity. Okay. And then we'll reduce the drag by 50% so that when it hits the target, the velocity would be pretty high. So we put in all the efforts and achieve both. Okay. But still what we come across is, although the bullet is penetrating the jacket to a certain extent, but the target is not being penetrated. So we have put in a lot of time, effort, money into doing all of these activities, but the output that we have achieved, it may be only a 2%, 5%, or maximum 10% penetration. So the output is not justified with the input or the efforts that have been put in. So if we have a completely different requirement, we have to take a completely different approach to like execute it.
Right.
So
Right.
that is where we have our own methodology to go ahead in such a situation. So what we do initially is, if suppose we have the same example, if we consider, if we have to make a bullet which has to penetrate the bulletproof jacket, then what we would do first is we'll do a problem definition or a product definition of how it should be. We will look into what kind of properties does the jacket exactly have. Okay, we'll understand the physics behind the working of the jacket itself, so as to have a complete understanding of what is exactly happening there scientifically. So once we have an understanding of it, we first validate if our understanding is correct.
Yeah.
So just to give you an example, if we come across an idea that this bullet proof jackets, they are made up of Kevlar. So these are elastic fibers, right? So in general, elastic fibers we can cut with a scissor or a knife or some sharp object. Okay.
Right.
So if we have this kind of an understanding, what we will do is we will take a small piece of Kevlar or whatever material is there. We'll take a cutter or a knife and we'll try if it is working. So what we are trying to understand is if cutting the threads can be an option to penetrate this.
Right.
Okay,
Right.
so to the third person, we may look like idiots, like what they are trying to do, like they are trying to make a bullet that is going to penetrate a jacket. What they are doing right now is taking a cutter and trying to cut the this small piece of Kevlar.
Yeah.
So, but what we are trying to do is we are trying to understand if this approach works there. Okay. So if the approach works, we would take this ahead. If it doesn't, we will go back, we'll try to understand, we'll have some other perspective, and then we'll come up with something and we will again validate it.
Yeah.
So validation is an important aspect of this. So this is where the modified lean startup methodology we apply a lot. it talks a lot about validation. So it says you have to validate your product, your market, the product market fit. So this is how we do the functional validation, we can say.
That's a brilliant analogy to understand R&D priorities for product
Yes,
development. I think it's a
yes,
great,
yes, yes.
like a lot of it makes so much sense if you think about Bullet as your product and like say the Kevlar as a barrier to entry, say something like that. So I think it's a great analogy for people to think of their product development in that aspect, and I think they'll get a lot ahead. So validation also, even I feel that validation has to be done in a smaller experiment and then scaled up if you see any kind of like you can scale it up gradually as and when you see more and more validation for what you're doing. So
Yes, yes, sir. So that is actually what we try, because when we are doing something new, the chances of failure at the start are more. So what we do is we build quick, cheap protos
yeah.
and test them to just check if the assumptions that we have, whether they are correct, and whether the approach that we are thinking of, whether it is correct.
Yeah, that
Yes.
makes sense. That makes a lot of sense. I'm glad I got to know this analogy. I feel like I'm gonna use this very regularly. So, what
Yes.
have been your biggest challenges while building new products?
Yeah. So the first major challenge that we come across is we are working on products into different domains. So, like kitchen automation is one domain, then there's farm mechanization, and every product that we work on like size wise it is different, functionality wise it is different, requirement wise it is different. So whatever learning we have from one of the projects, we cannot directly apply it on some other project. We have to start from scratch every time. We have to define it from the start. We have to understand the stuff from the start, and then we have to keep moving ahead. So every time it is a completely new learning for us. So that is the first challenge. The second challenge that we come across is like converting art into science. Like this farm mechanization and kitchen automation, most of the functions that we are trying to mechanize, they are done manually by humans. Okay, and they do not fit into any of the engineering boundaries that we have. Okay, like cooking a certain thing, we cannot frame it in terms of physics, right, or science. Like for designing, let's say, a beam of a for a structure, we know how to do it. We have the calculations, we have learned those in our engineering, and we know how to do it, so we can proceed with that. But here it's not the same. So first we have to understand the art, we have to get used to it.
Right.
Okay, and then we have to convert it into science, scientific parameters. Okay, like for cooking, what should be the temperature, for how much time it should be done, what are the other parameters, let's say pressure, force, etc., etc. So we have to convert it into science, and then we have to move forward. So that is a challenge in each of the project.
Right.
Uh, yeah, and the third challenge that we come across is like we have many young members in the team, and since these are like recently graduated engineers, they have a lot of enthusiasm and they want to implement whatever they have learned during their engineering days. So what they do is most of the time before validating stuff, they actually jump into the actual design, engineering design part.
Yeah.
So what we are trying to do is we are trying to first validate a lot of stuff and then move ahead step by step. So this is another challenge that we come across. But with time, as they get used to the validating a lot of stuff, this tendency of moving directly into the engineering design reduces a lot.
Yeah, definitely. I think that when a lot of these engineers, they get really excited about new technologies and new ideas, and they go ahead and build something, but then later try to figure out whose problem is it really solving and what is the problem it's really solving, right?
Yes,
So
yes.
I think that's one of the ways of killing a product, or building something that nobody will use, essentially.
Yeah.
So it's a good approach to start with the validation and then go ahead with the design and prototyping. That's a good
So,
approach.
because see, if we do not validate something and we go ahead, we may build a product, we may even build the best version of that product. Okay, but if it is not going to sell, the effort that we put in during the development, the manufacturing, and the setup of the manufacturing, that is like huge. So that effort should have significant returns as well, right? So if the returns are not going to be good enough, then putting all of those efforts, the efforts go in vain, right? The time, the money, the effort, everything matters. So when once we validate it, we are like pretty confident that okay, this is going to work. So even the management is like, okay, so we know that this is going to work. Whatever money we have to invest, maybe it may be like hundreds of crores, but it makes sense to invest because we have validated this is going to work.
So could you talk a little bit about how do you mitigate technical challenges that you face during this product development phase?
Yes, sure, sure. So we face a variety of technical challenges actually. So some of those are innovation challenges, some of those are like component number reduction challenges, some of them are weight reduction challenges. So we have like a different approach for each of them. So I'll give you an example for each. Like for the innovation challenge, in one of our kitchen automation products, we were having an issue with the grains getting stuck in the mechanism. Okay, so this was a dispensing mechanism. So we were trying to solve this problem. So initially we tried with two, three different approaches like changing the speed of the gate, changing the shape of the gate, but it was not working. So we thought of looking at it from a different perspective. So when we looked at it from a different perspective, we thought we came across that only the large size grains were getting stuck. So what we did was, if they are just going to get stuck, let us have something in between where they will get stuck and the gate still closes.
Right.
So with this, with this basic idea, we went forward and created a prototype. And to our amazement, we were surprised that it actually worked.
Right.
So the grains were still getting stuck, but the gate was closing, and there was the air tightness of the product was also getting ensured. So we then tried it like 200, 300 times, and like almost 99% of the times we were getting the gate closure.
Yeah.
So yeah, so looking from various perspectives is what we do so to solve such innovation challenges. There was one more challenge related to another kitchen automation product, wherein the mixing function was not being done effectively.
Hmm.
Okay, so we sat down together. We had a few ideas, uh, ideated a lot. Then we came up, I think 15 to 20 ideas we came up with. And from those, we evaluated all and shortlisted a few for testing. So out of the all the ideas, we shortlisted six, and we actually prototyped all six of them and tested them. So when we tested all of them, one of the three of those actually worked, but one of the three worked extremely fabulously. So what we also believe in one thing is whenever we are trying to solve one problem, our solution should be able to solve one more problem as well. So
Hmm.
if we are solving two or more problems with a single solution, that then the solutions becomes brilliant and novel. So with one of these solutions, the one of the concepts, the mixing was being done effectively. The second advantage was it was being done in 1/3 the time than we had targeted.
Okay.
So yeah, so I mean, we had targeted a time of 1 minute for the mixing to happen. This solution was doing it in 20 seconds. So that was fabulous. The third fabulous thing was that after the mixing was done, there was no necessity of cleaning the container and the mixer. Uh, yeah, the blade which was doing the mixing. So, I mean, we had not thought that the cleaning part also we would be able to achieve. But yeah, that was great. The solution that was generated was great. So that is one more aspect like we are looking into, that our solution should be able to solve two or more problems. Then one more innovation challenge we had, wherein we had to increase the functionality of a product drastically. So this is again related to one of the kitchen automation products. So current products that we have in the market, so if we want to do cutting operations with them, we have to change certain parts. So for a certain cutting function, we need to put in something. If we have to do some other cutting function, we have to remove this component, put in something else. Okay.
Right.
So yeah, so the maximum number of functionalities that we could get from these machines were 3 or 4, and the maximum number of outputs would be somewhere around 5 to 6. So what we thought was, why do we need to keep changing all of these stuff? Why can't we do all of those with a single mechanism? So that was like the definition for this product, and we went ahead. So what we did was, here we had to look into the evolution trends in TRIZ. So they have certain evolution trends of how technical systems have evolved in the past, and those trends are applicable till date as well. So when we applied those trends, from one of the trends we got an idea and we actually implemented it, and we were able to create a single mechanism in which we could achieve different functionalities. Moreover, we can achieve different sizes of the output as well. So previously the functionalities were 4 or 5. We could increase it to 7, 8. Moreover, the number of outputs which were around 6, which we could increase it to around 20.
Okay.
So that was a very drastic change.
Oh.
Herein we had, I mean, these TRIZ method tools we keep applying to solve such technical challenges. There was one more challenge related to component reduction. So when we had like the basic prototype lab proto done for one of the kitchen automation products, we came to know that in the BOM the part count was around 54. So from the cost perspective, more the number of parts we have, more the cost is going to be. And since this was going to be a cost effective product, we thought, okay, so we'll have to do some work so as to reduce the number of components. So again, there is something called as value engineering in TRIZ. So we applied that, and can you just make a guess by what extent we could have reduced the part count? The initial part count was 54. Can you just make a wild guess?
I'm assuming at least 10 components you should have been able to reduce.
10 components. Okay, so you are saying from 54 would have come down to 44.
Yeah, 20% reduction, I'm assuming.
Okay,
That's
okay.
pretty
So
low, actually.
actually, we were able to bring it down to 26.
Oh, wow. That's
Yeah.
almost half.
Yes, yes. Slightly less than half. Yeah.
Wow.
So Yeah, so TRIZ talks a lot about functionality. So when we looked into the functionality of each of the component, we were able to find ways in which we could like transfer the functionality of few components to the other. So that is how we reduce the number of components.
Okay,
Yeah, so that is why we were able to achieve such a drastic reduction.
that's nice. So you would do this through part consolidation, or how would you achieve something like that? Like I'm assuming that you'd consolidate a couple of parts together. Is that how
Yes,
you? Okay,
sometimes it is consolidation, sometimes it may be merging two parts, sometimes it may be eliminating a few parts and giving their functionality to some other parts.
okay,
So here in this specific task, we had applied all the three.
nice. This is a
Yes, yes.
that could
Yes, so
be actually a major cost reduction as well in the whole.
yes, that was a major cost reduction.
Yeah.
There was one more technical challenge which was related to weight reduction. So in the farm mechanization vertical, we have a sugarcane harvester project.
Hmm.
Okay. So the initial sugarcane harvester that we had, that was extremely heavy, and we were having a lot of issues with the working of the a few sub-assemblies. So some specific sub-assemblies were failing a lot. So back then, the weight of the this is like a tractor attachment. So the tractor was weighing like 2 tons, and the attachment to the tractor also weighed 2 tons.
Oh
So
wow.
it was extremely heavy, and there was a failure with one specific subsystem again and again. So we sat looking at it from all the perspectives. We took in all the inputs. We analyzed all the problems that we were facing. And again, the approach was our solution should be able to solve more than one problem. So the subsystem which was failing, we found out why it was failing. We made a change in such a way that we reduced the size of the subsystem as well. So what it did was not only it solved the failure problem, it also reduced the size of the entire attachment. So after this one iteration, we were able to achieve the functionality, like the failure which we were observing previously, that was eliminated. So the subsystem was working perfectly fine. Moreover, the weight was reduced from 2 ton to 1.2 tons. So
Okay.
this was one iteration. Then we again put it through one more iteration for more weight reduction, and we have reduced it to 800 kgs.
Wow. That's
Yes,
massive.
yes. So
And
from 2 tons to 800 kgs was achieved in a year.
okay. And in these iterations, would you change materials or would you change the design itself, or how would you approach it?
The materials we have not changed, we have changed the design itself. So
Okay.
as I said, we have reduced it in size.
Hmm.
Yeah. So like whatever is extremely necessary in that product for performing the functionality, we have just kept that so that the weight can be minimized.
Okay. That's great. So I think that's one thing that we see a lot of our customers trying to achieve as well. Lightweighting is something that we are core in our magnesium business. So that's good
Yes,
to know.
yes, yes.
Uh, Design plays a major role as well. I believe that you're working on a bunch of products, right? Like you mentioned the one on kitchen automation and the farm products, farm automation products, right? So could you talk a little bit about those products? And
Yes, sure.
yeah,
Yes, sir. So we have these kitchen automation products which are still in the design and development stage. We have one more domain in which we have two products. There's air purification, industrial air purification to be specific. So we have two products in that. One is a cyclone separator and another is a electrostatic precipitator. So these two we have been testing in our own facilities and we have been getting good results. Just to give you, some basic info of those. This cyclone separator we use for separating particles which are more than 20 microns in size. So in many huge industries, we have this large cyclone separators. But for small processes which need smaller in size, there are very few products available. So we have designed this one product and we have tested in one of our plants. So what we have observed is that it has a 90 to 92% efficiency of particle separation. So there's an interesting story related to this. So we in one of our plants we were testing this. So we wanted to test it somewhere else. So there is one plant where we have this powder coating facility. So we went to the plant head and asked him if we can assemble this cyclone separator there because this can separate particles which are 20 microns or more. So he agreed to it. We installed it there. Has been working fabulously, so much so that they are not ready to give it back. So this was like the first proto that we made, and we have installed it there, and it is still working continuously. So
That's
the
probably the best validation you can get in
yes,
the.
yes, 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 yes. So this is one of the air purification products. The other one is an electrostatic precipitator, which is used for separating particles which are less than 10 microns in size. Okay, so welding fumes, gases, etc.
Right.
Yeah, so we have been testing this as well in our plants, and we have been getting an efficiency of 90% here. So just to give you a clearer picture, the input particle count that we have to the ESP is like 18,000 particles per cc of air.
Okay.
And when the air comes out of the ESP, the particle count is reduced to 1800 per cc.
Oh,
So yeah, so that is why we call it like it has a 90% efficiency. So these two products are like they are like through the design part, and we would be launching them soon. We are also in talks with one of the major earth moving equipment manufacturer for implementing the ESP in their plants. So yeah, so these two products will be launching soon, and then related to the farm mechanization vertical, we have one is the sugarcane harvester, and one is a fodder cutting machine.
okay. So as an automotive, your company is majorly into auto components, right?
Yes.
Then when you were deciding on new products to develop, how did you choose on these products specifically that this is the market that we want to go for, this is the opportunity? Because these seem detached from your core business, right? So how
Yes.
did you end up choosing these opportunities in the first place?
So the basic thing was automotive manufacturing has been an established business, right? Established domain for many years, and for a few years it has plateaued.
Hmm.
Okay, so the idea was to look into sunrise domains, which wherein the growth in the future is going to be huge. So kitchen automation is one domain where we see huge change because nuclear families are increasing in the country, and you have both the husband and wife working. So cooking becomes an added work, right? So if that can be automated, a lot of time can be saved in that. So that is one domain which we think is going to have a lot of what we can say rise in the coming future. Similarly in the farm mechanization as well. So there are, I mean, labor issues are extensive in many parts of the country currently because most of the people are like migrating from villages to cities, and whatever workers or laborers that do the work in the farm, they are reducing. So that is one more area where mechanization has been increasing in the last few years and is going to increase in the future.
Spoke extensively about the systematic innovation that you're doing, TRIZ, right?
Yes.
How did you get introduced to it? And if anybody else wanted to learn this, maybe you could give a gist about TRIZ and how you got introduced to it and how anybody else could learn something similar.
Yeah, I actually got it introduced to one of our directors, Mr. Mihir Saundalgikar. So when I had joined, we were like, I mean, his strategy was we will start working on new products or rather novel products, which would have, which would be having like better value propositions than the existing product.
Hmm.
So he was looking for workshops or methodologies which could help us in doing so. So through, I mean, I and him, we went for these workshops. So I got introduced to this through him. Okay, and yeah, so if others want to get in, like introduced or certified into TRIZ, there are like people who have been through level 3, they are authorized to take sessions and certify others on TRIZ. So if someone wants to get known about TRIZ, for sure we can help in that. Also, if they want to get certified, we can help in that as well.
That's
So
awesome. I think that's something that we'll talk about
yes,
a little later, and probably if there's something that we can offer to the people,
yes, yes.
definitely do that. So,
To give you a gist of TRIZ,
yeah,
so this is a Russian, there was a Russian guy named Genrik Alschuler. So he was working in the patent office there. So while working, he came across that all of the patents that he was viewing, they had a few similar patterns which were causing the innovation, or the inventive step was caused by a few patterns. So he analyzed many patterns, like in lakhs. 2 lakhs is what he analyzed back then, like 40, 50 years ago. And he came up with 40 patterns, okay, which uh, the improvement that was there from the previous product, that if we consider to be one pattern, he found 40 to be in common in all of the 2 lakh patents. So he named them as 40 inventive principles. So this forms the crux of TRIZ, and that is from where the TRIZ journey started. So what we also do is when we come across certain problem, we like implement one of those inventive principles to get a solution.
okay, this
Yes,
sounds
yes. So this is not just like a philosophy or something. It has come from an analysis of the innovations which have happened in the past. And even after such a long time, there has not been 41st principle has not been found yet. So what level of analysis what that you can imagine?
so. Anyways, I think this was. I think I had a great conversation here. If anybody wants to stay in touch with your organization or stay updated about the products that you're working on,
Yes.
where can they do that?
Yeah, so I you can go to our website. you, right now you can find the manufacturing facility related details. So as and when we launch these products, for sure we'll be putting the details on our website. So our website is macpl-aitg.co. Okay, so you can go there. So if you want to know about the our group as well, AITG, Applied Innovation and Technology Group, you can go to our website, www.aitg.co. So there you can find information. So if you want to get in touch with us, or I'll have to request you one thing. Can you
Yeah.
put in our email IDs and contact numbers in the description of the video so that people would be able to get in touch with us?
No, absolutely, we can do that. And are you on LinkedIn individually or anything?
Yes, I am on LinkedIn, so you can search with my name, Akshay Akoode, Akshay Akud. You can find me on LinkedIn.
Perfect, perfect. I think that's a there's a lot of things that you spoke about. All of them so interesting. I'm glad we had this conversation. I got to learn so much more about your design process and product design in general. So I'm sure
Even
this
I
is
am happy I had this opportunity to share a bit of knowledge that we have gained from our experience in the last few years.
no,
So
absolutely.
hope this information would be helpful for people who are trying to do something new, trying to build their own startups.
If we have just 2 more minutes, I was with Mahindras and I was driving innovation for the entire sector.
Right.
Quickly speaking, through these workshops and all these initiatives, we have done close to over 500 projects and close to over 42 patents. So
Oh,
we used
wow.
to work on TRIZ, we used to work on biomimicry, as well as we used to work on orbit shifting. So all these three different methods are like religion or approaches to innovation.
Right, right, right.
TRIZ is what happens is TRIZ becomes easy for engineers. Biomimicry becomes easy for people who are into R&D sort of stuff. And orbit shifting is like people who are willing to make a drastic change in the process and heavyweight cost reduction initiatives.
Right, right, right. That's so cool. I think the way that you've done solved a lot of these problems that the technical challenges that you were talking about, when you were going through them itself, they sounded so interesting and so innovative in its approach itself. And now that you mentioned biomimicry and all of those things, I'm assuming those must be the principles that you're using, right?
If you look at biomimicry and trees, the algorithm is literally the same.
Okay.
You have to understand the function. In trees, you understand the function and define the contradiction. In biomimicry, you understand the function and search for organisms that would perform similar functions and translate that into design for your product.
So
Yeah.
what basically one philosophy in TRIZ says is whatever problem you are trying to solve, someone somewhere has already solved it.
Yeah.
So you can look into other industries where a similar function related problem has been solved. Try to implement it in your field as well. So biomimicry is like you look into nature for what strategies or ideas has nature used for solving problems. You can implement similar solutions to your problems as well.
Just to ignite and kindle your curiosity, there is a building in Zimbabwe which is called East Gate Building, if I remember the name right. So they have taken in biomimicry to solve the cooling mechanism of the entire building. You know, Zimbabwe, the temperature range is pretty high.
Right, right.
So they have taken inspiration from the ant mold. Ant
Oh,
molds, you have heard of it, right? So they use 10% of the actual energy required for the cooling system.
wow.
Just
Okay.
10%. So in one of the projects in my previous organization, we had a mechanism which was becoming mandatory in the farm equipment, and the weight was way too high. So when the weight is way too high, it would add about 20K to the price of the product. So when we concluded the product, it came down by 60% of its actual weight.
Oh, wow.
So that's how, you know, the only thing that that you have to understand is your problem has been solved if you can convert your problem into raw generic form.
Right, right.
So it requires a little bit of talent, a little bit of mentoring and molding to come through that.
Yeah. That's great. Where can people follow you as well? Are you on LinkedIn by any chance
Of
or
course,
Twitter?
I am on LinkedIn, SS Narayan.
Okay. Perfect, perfect. Glad to get introduced to both of you and have this conversation.
Yeah, great.
Great, great. Thank you. Thank
Thank
you very
you.
much.
Thank you.